Today you will be writing and graphing quadratics in standard form. So if you remember, vertex form, which is what we talked about earlier, is this y equals a parentheses x minus h quantity squared plus k. And we have an example off to the right, the parabola y equals quantity x plus 3 squared. And remember, the vertex of that parabola is at -3, 0 with an axis of symmetry of x equals -3. We see our parabola off to the right in our sample picture is the equation y equals x plus 3 quantity squared. Well, standard form is just the y equals ax squared plus bx plus c, which should look familiar because we spent a huge chunk of the first part of Unit 2 factoring trinomials. Well, if we look at y equals x squared plus 6x plus 9, isn't that the same thing as y equals x plus 3 quantity squared? Yes, right? Factors of 9 that add to give you 6 are positive 3 and positive 3. So it does factor to y equals x plus 3 times x plus 3, or y equals x plus 3 quantity squared. So both of those equations graph the same parabola. And that leads us to our first type of problem. We want to identify the vertex, the axis of symmetry, the max or min value, and the range of the parabola y equals 2x squared minus 4x plus 5. Well, the first thing we need to do is figure out how to find the vertex. When a parabola is written in standard form, to find the h-coordinate of the vertex, all you're going to do is you're going to do h equals -b divided by 2a, right? So my a value is 2, my b value is -4, and my c value is 5. And we just plug and chug, okay? So I'm going to have my negative, and -4 is b, all over my 2 times a. So 2 times a, 2 times 2. So our numerator is just 4, and our denominator is 4, and we get an h value of 1. Once we have the h-coordinate of our vertex, we can find the k-coordinate by just plugging in h into the original equation. So the y-coordinate of my vertex is equal to 2 times 1 squared minus 4 times 1 plus 5. And you would type that into a calculator exactly like you see, including those parentheses. It should give you 3. The next thing we're going to do is we're going to identify what the a value equals. Remember, a is the coefficient of the x squared, and we've already identified a as 2. All that's left for us to do is to write it in vertex form. Y equals our a value 2, parentheses, x minus h squared plus k. So now we're ready to answer the questions at hand. Our vertex, remember, for the x-coordinate, I'm going to take the opposite sign of the h. So our vertex is at 1, 3. It says we're going to find the axis of symmetry. Our axis of symmetry is the vertical line x equals 1. Remember, it's the line x equals h. Now, is this parabola open up or does it open down? Well, because the a value is positive, it's going to open up, which means we have a minimum value when the y value is 3. Remember, the min or max is always located at the k value. And then remember, domain for parabolas is always going to be -infinity to infinity, but the range, if it opens up, then that means I have a minimum y value. And I'm going to start my range at that minimum y value, and it will go increasing forever. Now I want you to take a second and try the example you tried. So if we look at the next type of problem, we're going to graph y equals 2x squared minus 4x plus 5. And we're going to find the vertex. Now we actually have already done this problem. We did this on the previous slide. And we found our vertex to be at the ordered pair 1, 3. If you have forgotten what our vertex form was, remember it was y equals 2 parentheses x minus 1 quantity squared plus 3. Now we're going to graph the parent function and shift it. If you have forgotten how to do that, remember what we did is we put a box around what it is we're doing to x. Okay, and we're going to graph the parabola y equals 2x squared. And we're going to use negative 2. Oh my goodness. Why won't it let me write -1, 0, 1, and 2? And we plug those values into y equals 2x squared. For -2, you should get a value of 8. For -1, a value of 2. 0, 0, 1 is 2, and 2 is 8. Now we're going to plot those points on our grid. Once we get those points plotted, now we're going to look at our shifting. So if we look at our original vertex form, notice this -1 means we're going to move to the right. And this +3 at the end means we're going to shift up 3. So all the points we just graphed, we're going to move right 1 and up 3. And now we're going to draw our parabola. And that's it. Now I want you to take a minute or two and try the example you tried. This is the parabola you should have. Keep in mind the curve should not be squiggly. Okay, any questions? If we look at the next type of problem, it says we're going to write y equals -x squared plus 8x minus 5 in vertex form. Okay, so to write it in vertex form, we are just going to do the exact same steps. So the first thing we'll do is we'll find the h, which is the x-coordinate of the vertex. To find h, we do -b and divide it by 2 times a. So -8 divided by 2 times -1. And that does end up giving us +4. Our k value. Remember to find k, you're going to take the h coordinate or the x coordinate of the vertex and replace the x's with that h. And you'll type that expression into a calculator exactly like you see. I think it's 11. And your a value is -1. Now we have enough information to plug our values into vertex form. So y equals -1 x Hopefully you find that y is equal to -2 parentheses x plus 2 quantity squared minus 2. If we look at the next type of problem, it's going to ask us to write y equals the quantity x minus 2 squared minus 1 in standard form. Now, in order for us to write this in standard form, we'll start off with y equals. And if I see x minus 2 quantity squared, remember I have to write x minus 2 twice. And then we have to distribute, also known as FOIL, those parentheses. So the first would be x squared. The outers would be minus 2x. the inners would be minus 2x, and then the last would be positive 4. And then all that's left for us to do is to combine like terms. So y equals x squared minus 4x plus 3. And that's it. That's all you have to do. Now I want you to take a minute and try the example you tried. Hopefully you found the answer to be x squared plus 6x plus 13. And in our last type of problem today, it says we're going to graph given the vertex is at negative 2, 10. Okay, so that's my h and my k. And my intercept is at 0, 6. And that's another point, x and y. Now, it doesn't hurt to draw a little sketch. So our vertex is at negative 2, 10. And 0, 6 is our y-intercept. Now remember, parabolas are symmetric, and my axis of symmetry is going to be the line x equals negative 2. So that means I also have a point at negative 4, positive 6. And we could go ahead and sketch it if we want to. Remember, don't make them curvy. Now, if I needed the equation, we have to find the a value. So if we remember our vertex form, y equals a parentheses x minus h quantity squared plus k, and we plug in y, which is 6, the a value we're trying to find, the x value is 0, the h value is negative 2, and the k value is 10. And we just do some basic algebra. So we'll subtract 10. Negative 4 equals a times 4, or a equals negative 1. So y equals negative, parentheses, x plus 2 quantity squared plus 10. And if you want to put a few more points on the graph, you can. The only other points I would suggest would be negative 1, 9, and negative 3, 9. And that's it. That's all you got to do. So now I want you to try the example you try. So hopefully you have a graph similar to what is in red. Again, they should not be bendy, they should be straight. And the vertex form is y equals 2 parentheses x plus 1 quantity squared minus 2. And we have officially made it to do some practice, the end.